right, I'm going to try the subtitles. We'll see if it works. Hey, okay, all right. Good afternoon, everyone. Check my watch. It is now the afternoon. That's good. So thanks very much for being here, everybody. The session I want to talk about is how we can look about deploying machine learning models faster by looking at things like DevOps and DataOps. So my name's Terry McCann. You can find me on Twitter at SQLShark. I run a consultancy with Simon, who you've seen already this morning, called Advancing Analytics, and we do a whole load of stuff. If you're interested in data science, then I thoroughly recommend you check out our podcast, Data Science in Production, and you can continue your learning. Okay, so we've spoken a whole load of stuff about DevOps. We've looked at various different things today, so I'll try and skip over anything where we've already gone over a lot of this. But DevOps, for me, fundamentally is attempting to stop this kind of process, right? I'm a developer. I write some code. And then what I do is I just kind of lug that over the wall to operations. And I'm like, haha, your problem now, yeah? That's kind of what I want to avoid. And I'd love to say, like, that doesn't happen, yeah? We'll all work together with this cohesive DevOps, DataOps team. But, you know, in reality, it's not quite like that. And these roles are still very separate. And a lot of the time, that does kind of happen. So how do we stop that? Yeah, we've seen this. We bring these two guys together, and we form our DevOps team. So let's just quickly go over a lot of the stuff that Alex has gone over already. So, you know, fundamentally to DevOps, to DataOps, it all starts really with culture. If we don't have buy-in, we don't have buy-in from the business, then this stuff is very difficult to actually get any traction with and to get this stuff working. It's hard to get DevOps and DataOps to really work in a small team when the rest of the organization works in a fundamentally different way. That next part, if you imagine it's like a big old pyramid, that baseline of that pyramid is version control. And I think Alex did a good job of hammering home, yeah? Like everybody who didn't have their hand up who's not using Git, you know, start using Git. It's a very good way to really get into some of this stuff. You can check out our GitHub pages and stuff, and you'll find a whole load of things on there, and use that as your first example of trying to get started with Git. So then we have all these other things on top that everyone else has sort of discussed a bit today. Continuous integration, continuous deployment, infrastructure as code and configuration as code, automation, and then ultimately giving our operational teams that kind of feedback that they really need to guarantee that this stuff is really working. And so there's a lot more than just tech. It's sort of those things. There's a whole lot of stuff in there. But when we start talking about, you know, how does this work for machine learning, then we need to start thinking about this stuff maybe in a slightly different way. Because, I mean, DevOps is really designed to accelerate software projects into production. And you can look at machine learning projects, and on the surface, they kind of look a little bit like a software project. But there's a fundamental difference. It's a fundamental thing that really makes it a whole lot harder. So, I mean, you know, why is DataOps different to DevOps? And I think for me, the key really is this guy, Data. I like this screen, but it makes my eyes hurt after about 2 seconds, so we'll just go for plain gray. So data is the thing that really makes DataOps or DevOps for any data-intensive application really hard. Because we talk about version control, and you start talking about machine learning, and you think about what goes into a machine learning model. Well, I take some data, and realistically, that's going to be quite a lot of data. Ideally, when I'm building a machine learning model, I'm trying to pick a data set that is going to generalize nicely to the problem that I'm trying to solve. And to get a good generalization, we typically need a lot of data. So I take a lot of data, and then I build out a machine learning model. So I write some code, I build a REST API, I build all these great things on top of it so that it actually works. Then I try and version it all. So I version control my data, I version control my code, I put everything inside Git. Great. And then I come down a couple of weeks later, I need to retrain this. I've got some new data. So I add this new data on top. So I had 2 gigs of data before, maybe I've got 3 gigs of data now. In my version control system, that ends up being 5 gigs. And we go through this process, and it gets bigger and bigger and bigger, and data becomes a bigger and bigger problem. So versioning data is hard, but there are ways that we can do this. I won't cover it massively today, but things like MLflow are a great way of trying to do model management and versioning of your data. So data is fundamental to AI. It's fundamental to machine learning. If we don't have data, then we don't really have anything that we can work with. So very quick, what is machine learning? This is from the 7 steps of machine learning. Comes from a Google advocate whose name I do not remember. But they say the first step of machine learning really is that gathering data. It's going out to the business, it's trying to find a problem, it's trying to find the data that will accurately portray that problem. We then prepare it, we visualize it. There was the comment this morning that 80% of data science is just prepping data and munging data. And realistically, yes, it is. As a consultancy, we try to build out solutions that break that number down. I'd love to say that we have a silver bullet that makes it like 0 and you just don't have to do that. But in reality, you do. We can realistically bring it down to like 40%, but it's still roughly about 40%. There's still a lot of stuff there. Then what we do is we select some kind of generic algorithm, yeah? We take something like a regression model for trying to predict something numeric. Maybe I'm trying to do some kind of classification. Is something fraudulent or not? I take that algorithm, and then basically I just kind of like mush these two things together. So what I'm trying to do is I take this generic algorithm and my data, and what I'm doing really in machine learning is I'm tweaking a whole load of parameters with the intention of creating something that generalizes to the problem I'm trying to solve. I evaluate that model. Is it a good model? Does it work? How do I know it's a good model? When should I stop? These are all interesting problems that we can discuss maybe after the talk. Then what I do is a bit of hyperparameter tuning, yeah? I try and squeeze that last little bit of performance out of it and really get it into the best state possible. And then I use that to create new predictions. So I run some new data through it and I see how well it worked. So this is known as the 7 steps of machine learning. And you'll see this kind of process flow in most machine learning books, in most data science books. That sort of take you this far. You can look at things like CRISP-DM, the cross-industry standards for data mining, and they'll also kind of take you this far. But the one thing that they don't ever really talk about is then actually deploying this stuff, right? I've spoken to many different teams, and I've tried to hire data scientists before, and you ask them a question. You say, tell me about a machine learning model that you built that was something really good that you're passionate about. And they can talk, and they can talk, and they can talk. And then you say, great. OK, so tell me how you put that into production. What did you do to actually get some return on investment on that product? And then they start, the calls sort of go a little bit quiet. People start getting a bit cagey. And then they sort of say, well, actually, somebody else did that for me. Or, well, actually, we never got that far with that particular thing. And that is a huge problem for most data science projects. So if 80% of data science is spent doing munging and doing data preparation, there's this even worse statistic, which is 80%, which is 80% of all data-intensive projects fail. Be that a business intelligence project, be that machine learning, large amounts of these projects fail. And typically that's because people can't get this stuff into production. So productionization in machine learning is known as the toughest problem in data science. And when I first started looking at this a while ago, this comes from a book from 2014. It's a very good book. There's a link just at the bottom there. And to me, that felt like, yeah, surely not, right? That's not the right thing. That's not the hardest thing. That's not the toughest thing. The toughest thing is, it's me learning deep learning, knowing whether I should use Keras or Torch or which algorithm I should do. That stuff is hard. Don't get me wrong. That stuff's hard. But we can find people that can do that. Finding people who can productionize models and get that stuff deployed, that's a lot harder to achieve. So why? So let's take a little look at my beardy friend here, the data scientist. Let's describe a little bit about the typical data scientists we end up working with. They're generally very highly academic, quite statistically minded, typically have very advanced degrees in a very narrow field. It's a great thing, when we go and hire somebody with a PhD, yes, of course, they are very smart, but they are very smart in a very narrow area. They're particularly strong potentially in machine learning languages, in R, in Python, in something else, but they're not necessarily from a software background, which makes getting things into production quite tricky. They think testing is hard. Testing is hard, yeah, testing's hard. They don't necessarily use version control. Maybe we've seen that here. Thinks deployments are the responsibilities, maybe for another team. And that also gets further complicated when we look at the amount of languages that we potentially want to work with. Now, when we work with data science teams, what we don't want to do really is say, well, actually, I know that you know all that great Python stuff, yeah? But we're an R shop. We just build things in R. Forget all that good stuff that you know, and you're going to become an R developer. Or the flip. We don't want to do it the other way around. If you come out of university, if you come out of another position, and we hire you, and you know how to build machine learning models in Scala, cool, so be it. We need to build out architectures which support multiple languages, which again is very hard to achieve. So as a result, models aren't in production, teams are suffering to achieve any kind of return on investment, and people are looking at them when they're looking at cost saving. So we had sort of, when DJ Patil said that data science was the sexiest job of the 21st century, everybody rushed out to try and build out these data science teams, yeah? And then typically, lots of them have struggled to achieve a return on investment, and lots of them sort of fall by the wayside. People leave, they aren't rehired until these teams dwindle, and they basically become a business intelligence function supporting dashboards and that kind of thing, which we don't want. So models aren't in production. How do we fix this? It's our friend automation, yeah? We've seen this guy quite a few times today. What's one way that we could look at that? We're going to see how far we can get through some of this stuff. But one option that we have is if we want to support something which is truly generic, which truly supports both multi-cloud, multi-vendor, on-prem, hybrid, multiple different languages, then we don't necessarily want to couple into a single technology. We could use something a bit different. So here, I'll try and show you in the rest of the time that we have a process for using DevOps to basically narrow the focus of a data scientist so they don't necessarily have to know how to productionize a model, but what they can do is focus on the stuff that they know well, building out models, training, hyperparameter tuning, and then what they do is they just store that stuff in Git, and we'll lift up the whole rest of it, and we'll get it deployed into a Docker container, onto container registry, and then ultimately into Kubernetes. I have a whole load of stuff here, but in the absence of time, by all means, I'll share this stuff. This is what Docker looks like. If you've never seen a Docker file before, it inherits from a base image. We'll be using Python. We will be looking at some of this stuff, right? So what we'll be doing is we'll be building out a Docker image for a machine learning model. Here we can host anything in there. If it runs on Linux, we can run it. So if it's R, Python, if you want to run Julia, you want to run something else, we can do that. And we'll build out an image, and we'll host that, we'll run that as a container, and then we'll have an application talk to it. And then one of the interesting things that we'll look to do is we need to get something running. So if we build a machine learning model out inside a Docker container, that's great. That Docker container can run on my laptop. But I mean, that's not really solving the problem of production. That's solving the problem for lots of teams where production is just running stuff on their laptops, but we want to be running this in a proper service. So we're going to need to deploy that. And we can do that by hosting our models inside a container registry. So that container registry could maybe have version 1 of our machine learning model, and then as we mature over time and we retrain, that could also hold version 2 of our model. And we were having a discussion over lunch about cattle versus pets, and about how we don't want to necessarily build out stuff like cherish it like a pet. We always want to think of it as cattle. If this stuff dies and we spin it back up, it's okay. I'm a vegetarian. I like cattle and I like pets. I don't want any of them to die. That's another discussion. So in our container registry, we can have multiple different versions of our model, and then we can have additional ones. And it's here that we're going to have something look at that and lift those up and try and run them. And that one is going to be Kubernetes. If nobody's looked at Kubernetes before, this is the fastest history you'll get. Kubernetes, the world basically runs on Kubernetes. If you try and use any Google service, you will inevitably be running on something hosted on Kubernetes. So it came out of Google. Google had this software called Borg. Borg was basically built to try and work out how they could host all these various different containers. It was incredibly proprietary. And they basically uplifted that with another tool that they built internally, again, called Omega. Again, remained very proprietary. They attempted to try and outsource it to open source it, sorry. But it was too tightly locked into a lot of their processes. It became very hard for them to do it. So what they did was they tried to supplement that into a new tool known as Kubernetes. But ultimately, Kubernetes shares the same kind of DNA with all of these tools. And they are slowly shifting everything to run on Kubernetes. Basically, as I say, the world runs on Kubernetes. All right, so let's have a look at some way that we can automate some of this. So we're going to have a little look at Azure DevOps. We're going to look at a pipeline, and we're going to look at our release activity. We're going to have a look at a very basic machine learning model. Let's have a quick look at the machine learning model itself. it looks a little bit like this. It's a very dummy data set. It's not particularly doing anything interesting, but we're doing some interesting stuff in it. So the actual machine learning part is pretty much just this section here. This is Python, for anybody who's not looked at Python before. We take in some data, we do test, train, and we split our data. So basically, we take 80% down one way, we take 20 down another way. We build out a model, and we test it, and we validate it with the other 20%. So we're building out a model, and then what we're going to do is we're going to fit that model, and then we are going to use that to pass some new data in to basically come up with a prediction. So this is using a Python framework known as Flask. And Flask will wrap an API around my Python model, enabling me then to be able to use that as an endpoint for maybe my piece of software or something to push some data to and to get an easy response back. It's a nice, simple way to just put an interface on top of my machine learning model. I've got two interfaces there. I've got one for training and one for scoring. If I want to, I can call train, and it will retrain my model. I can call score to get a response back. So that's my model. What I want to do is containerize that, so get that running inside a Docker container. And all I basically need to do to get that running inside a Docker container is to take that code and build myself out a Docker file. And a Docker file basically just tells Docker how it's going to start working. So we say, I'm going to infer from a base image. And that base image here is Python 3. And that dash on build is just a function to say, basically, you're expecting to find a requirements file which is going to have all of my packages in. It's going to manage dependencies for me. If you do this stuff, I don't recommend doing it in this way. Because what we're trying to do is we're trying to create something that when we deploy it once and it dies and we redeploy it, it should be exactly the same. That little from Python 3 is going to grab me the latest version of Python every time. Really, we want to say, grab me Python 3.7 or something like that and run with that. And all I need is that, and I can ask Docker to build me out an image, and then with that image, I could push that to a container registry. But what we want to look at is some DevOps. All right. So here's one I made earlier. So this is Azure DevOps. For anybody who hasn't seen it before, this is Microsoft's DevOps tool. We've got a couple of things over here on the left. We've got boards. So if you use Jira, we can have all of your tasks in here. You can associate them back to your repos. We've got Git, we've got TFS, and you've got pipelines, and we have releases in here as well. So that pipeline, that gives us that CI element, the continuous integration. The releases, that gives you that continuous deployment element. So we do our CI to get our stuff prepared. We get it tested, and we use the CD to get that then deployed. So we've got two things here. We've got one pipeline for each. This is the first one. We'll just edit it. And all that's happening is basically it's going to look at my Git. So I've got Git already set up. It's going to do two things. It's going to do a build and push into a Docker container registry, which I've got set up in Azure. And then it's going to do a publish artifacts. So it's going to pop that somewhere that I can then pick up with a release task. And what I have is I have this set up so that anytime anybody makes a change to that on my on sort of like my release branch, it goes into production. So this will be prepared. And what I'd ideally do here is I'd start layering in a whole load of additional tests to make sure my stuff works. How do you test machine learning? That's a good question, probably for after the session. But once that's all gone through and everything's happy, the last thing that we have is a release task. And what that release task is going to do is attempt to release this into Kubernetes. I have got some stuff running here, just purely to show you, and I'm already running out of time. 0 time. Look at a minute. The last thing here is this is a Kubernetes dashboard. And what Kubernetes dashboard will show you is I have a deployed model here, gives me an endpoint. And what you can do there is you could run something like this guy. This model is super simple. If I run that one, what that's going to do is that's going to go away to Kubernetes, and it's going to score my model based on this, based on that parameter, which is basically working out my level of diabetes. And it will happen in real time if the internet works. Slowly it's getting there whilst it warms its stuff up. There we go, just what we wanted to see, yeah? All the best demos work this way. Cool. OK, so we can use DevOps essentially to accelerate the stuff into production and get things working a bit quicker. Now, that's a lot of stuff to try and cover off in a short amount of time. So if you want to have a look at this stuff, we've got a huge amount of this content on our website. So you can go away to advancinganalytics.co.uk. We basically have a condensed kind of book in blogs, which looks at DataOps and deploying models faster. I say go and check out some stuff. There's our details there. Start learning how you can get models into production and automate that which is difficult. So reducing that time to production, control, test your code, monitor, and get stuff into production, really. Cool. Thanks very much. I would also say, if you're interested in this stuff, I'm doing a talk in a couple of weeks for Minds Mastering Machines in London, which goes through all of this stuff, but basically over a day and not in 20 minutes, which is slightly more conducive to understanding some of those topics. So have a look at M3, which is Minds Mastering Machines. Questions? Cool. Yeah?
I don't know if this is a stupid question, but with source control of the model,
Yep.
is this actually like a problem people have? Is like, how do you manage source controlling the training data with the model?
Yeah.
And that's something you tend to do in like kind of real life.
Yeah, so it's a great question. So it really, if you work in a highly regulated industry and you build something which maybe interprets whether or not somebody could have something. So say you work for an insurer and you have a little thing that sits there and it works out whether or not somebody can have an insurance policy, and maybe somebody says, someone gets annoyed and they involve a regulator. And we're getting into the realms where regulators could start asking for things like, OK, well, what I want to see is I want to see every element that went into that algorithmic process. So I want to be able to see the code that you use to build your model. So just to ensure that you're not putting any biases in there or anything like that. I want to see the data, and I want to see all of these things. And if you build your machine learning model out with some data, and then you retrain it, and you retrain it, and you retrain it, and you're not capturing that history, then you're not able to do that. You have no reproducibility, and it's very hard to get back to that original state. So that's why tools like MLflow, which will basically capture your data, store it maybe in blob storage, or a data lake, or an S3 bucket, or something like that, help you with that. So you've always got a lineage of that data, so that you can hopefully rebuild back from it. And even if you couldn't, you do enough to appease regulators, which is ultimately all you need to do.
Very pedestrian question. Develop and that's how operationalize that model.
Yeah. So the question was, would you recommend using cognitive services for, for a trial basis? I would recommend using cognitive services. If you can solve your problem with a cognitive service, just solve it with a cognitive service. Ultimately, if I look at some of the cognitive services that exist, so I look at things like the form recognizers or some of the custom vision stuff, which is also tomorrow evening I'm doing a talk on custom vision here at a user group. But if I look at some of that stuff, then there are huge teams that have gone in to build that stuff, and most of them are backed up by Microsoft Research. I like to think that I can do a lot of this stuff. Can I do it as well as Microsoft Research can? Probably not. So use a cognitive services if it will solve your problem, because you can guarantee it's been probably built very well.
And so it'll be easier to operationalize it as well.
Oh, 100%. Yeah. Because what we try to do is we try to build things out with APIs.